Hello, algebra students, and welcome to 11.6 continued, because we've been doing a lot of 11.6 simplifying square roots, and today we're going to talk about what happens if there's a square root in the denominator, because we don't want that. So let's quickly do a little review of what rational and what irrational means. Rational numbers are basically any number you can think of: whole number, decimals, fractions. Irrational numbers, there's kind of two big ones: pi, and then the square root of a non-perfect square. And I'm not going to put anything under that square root because technically, like, the square root of 16 is technically a square root, but guess what it actually is? Ooh, you can barely see that. Let me try that again. It's actually a 4. And so because it's actually a 4, it's technically rational. That doesn't look like an R either. So square root of a non-perfect square, the square root of something that can't be a whole number. So the square root of 6, is that giving me a whole number? Nope, that's irrational. Square root of 10, is there a perfect square? Can I simplify it anyway? Nope, that's irrational. Square root of 18, is that going to give me a decimal or a whole number? That is irrational. There's one that's rational over here. See if you can figure it out. Yep, the square root of 9 is 3, and so that's technically rational, whereas these 3 are irrational because they're not simplifying to be like a whole number or anything. So our goal today, when we say rationalizing the denominator, we want our denominators to be rational. We want them to be whole numbers or simplified square roots. So our essential question today is simply, can I rationalize the denominator? And our main goal today is to get any square roots out of the denominator. We're going to start with irrational denominators. We want to get rid of those. So leave some space up here because we're going to come back. We're going to leave like some little reminders to ourselves up here. But we're going to start with an example. Give yourself 4 or 5 spaces and then get ready with example 1. Because I think it's sometimes easier for us to start with the example and see what problems we'll run into. So here is our first example. 7 divided by the square root of 5. We do call this rationalizing the denominator, but it does fall under like simplifying this radical. We don't want radicals in the denominator. We need to figure out what to do. And I'm going to show you what to do. If the denominator is the divided by, or the denominator is the square root of 5, we're going to multiply that by the square root of 5. I'm going to show you why you do that. So let's jump back up here. If I have, whoa, we got pens everywhere. If I have the square root of 2, and I multiply by the square root of 2, guess what I'm going to get? The square root of 4. And what is the square root of 4? 2. Let's do it with something else. Square root of 6 multiplied by the square root of 6 is technically the square root of 36. And what is that simplified? 6. And you'll start to see a pattern. The square root of 18 multiplied by the square root of 18 is equal to, I think it's like 324. And what's the square root of 324? It's 18. So you'll start to see this pattern that if I start with the square root of 2, well, I can just multiply by the square root of 2 and I get 2. So that's why we're going to come back down here. And we're going to multiply the denominator by the square root of 5. Because that will give me a new denominator of 5, as we just saw up here. Now, I don't like to use the word problem because it's not a problem that we're having. It's just something we need to remind ourselves of. If you multiply something in the denominator, you have to do the numerator as well. Because we don't want to just change the denominator and not touch the numerator. We want to do both. So if you multiply the denominator by the square root of 5, you also need to multiply the numerator by the square root of 5. So my numerator is 7 square roots of 5. At this point, you start checking off the boxes. Did I get the irrational out of the denominator? Yes. Can I simplify any fractions? No. Is my radical simplified? Yes. And you are done because your goal was to rationalize the denominator. The denominator looks pretty rational. I think we're ready to try another one. Let's look at example 2. Example 2 is 6 divided by the square root of 2. So let's look at this problem. When you see a square root in the denominator, you want to multiply by that square root again because that's going to give you a rational denominator. But whatever you do to the bottom, you have to do to the top. You can't leave him out. What is 6 multiplied by the square root of 2? Well, it's just 6 multiplied by the square root of 2. You can't simplify that at all. And at this point, you ask yourself, am I done? I radicalized the denominator. Check. But one thing I have not done is I need to simplify that fraction there. And so in this case, it's 3 roots of 2 over 1. Or you could just write it as 3 roots of 2. You wouldn't have to put that one there. So let's try a third example. Our third example will do, let's do this one. 2 divided by the square root of 6. Okay, there is a radical in my denominator. It's not rational, so I can make it rational by multiplying by the square root of 6 because that's going to give me 6. So that's why I'm choosing to do it. But then I also have to do the top 2 because we can't just do the denominator and not do the numerator. Okay, at that point we've rationalized my denominator, but why am I not done? I'm not done because that fraction out in front is not simplified. What number goes into both 2 and 6? 2 does 2, whoopsies, 2 goes in once and 2 goes in 3 times. So in my denominator or numerator, I just have the 1 square root of 6 over 3. Can I simplify any fractions? No. That 6 isn't a square root, so you can't touch him. And at that point, you are all simplified. That is what you were doing today. If you need something to refer back to, make sure to watch this video again or look here, and we're going to continue on with this tomorrow as well.